Hello, in this video we are going to present a project which we were working on during our project internship at Bennett University. Our project was on click fraud detection. When we browse online, we see a number of advertisements. When we click on these ads, the advertiser pays the publisher a fraction of money for every new user they bring in. This, in layman terms, is pay-per-click revenue model of online advertising. Pay-per-click revenue model is highly prone to click fraud, which annually results in the loss of billions of dollars from the pockets of the advertisers. Usually, rival companies take advantage of this pay-per-click revenue model and incentivize dishonest publishers to generate fraud clicks, which pose a serious problem to sustain a healthy online advertising market.
Manual detection of fraud clicks is a tedious process because the data is huge and complex. When we are going through the previous research papers, we have found that many attempts have been made to automate this process using techniques like gradient boosting, ensemble learning, and few other machine learning techniques. Only non-fraud clicks get paid according to pay-per-click. So we have to minimize frauds being classified as non-frauds. That is, we have to minimize the number of false positives. We have built a deep learning neural network which is robust and fast, which classifies frauds and non-frauds efficiently. We have obtained real-world dataset from industry. It has 43 features and 1.5 lakh data entries. Our model has one input layer, one output layer, 3 dense hidden layers with 2 dropouts and batch normalizations in between. We have achieved an accuracy of up to 98% approximately. Our model has one input layer, 3 hidden layers and 1 output layer with 2 dropouts in between and batch normalizations in between.
The Jupyter notebook is divided into 3 parts: pre-processing, training the model, and testing. Here we are fetching the data from 2 different files, one being fraud data and other being non-fraud. This data has over 1 lakh entries. The data can be seen here. It is very complex. It has 43 columns and all the data entries are complex. Here we are dropping the unnecessary features. Here we are converting the complex entries into numeric values using label encoder. This is to impute the zeros and null values with the mean of each column. Now the data is like this. Now we can work on this data to pass through machine learning or deep learning models. We have used 2 correlation methods for pre-processing. They are Pearson correlation and Spearman correlation. This is Pearson correlation and this is sorted values of Pearson correlation with respect to fraud, and this is Pearson correlation matrix. We have used Spearman correlation also. These 2 were used during data pre-processing. Now we are splitting the data into test and train sets with 20% of data as test data. This is to print metrics and confusion matrix. Now let's use machine learning techniques. Starting with Gaussian naive Bayes, when we train the data and using training data and test data using test data, the accuracy is 74%. And similarly, when we use logistic regression, the accuracy we got is 77%. As seen previously, some data elements are large and some are small. So we normalize the data using min-max scalar first and standard scalar next. Now when we pass the same data through Gaussian naive Bayes classifier, we got the accuracy up to 77%, and logistic regression also gave the data accuracy up to 95%. Now the same data is also passed through SVM. Now it gave an accuracy up to 98% with 46 false positives only. Now we will proceed further with deep learning. Here we have imported all the necessary libraries. Here we are declaring batch size of 128 and number of classes as 2 as they are fraud and click, and we are assigning 30 epochs. As we are working on neural network, we are converting Y into categorical form. Now, this is our neural network has one input layer and one output layer and 3 dense hidden layers in between. Input layer has 31. Input layer is of size 31 and output layer is of aftermath with 2 classes. And we used 2 batch normalization and dropout twice in between. Now we tested the model with the same data, and we got an accuracy score of 98%. That is almost 98.7%. That is almost 99%, and with loss of only 4.6%. Here we got only 21 false positives, as seen in the confusion matrix. Here we have plotted model accuracy curves of both test and trained datasets, and here we have plotted model loss curves of trained and test datasets. Here we can see the variance and bias is low, so that data is accurate. So we can say that this neural network model can be used for classification of fraud click or non-fraud click, and this gives a better accuracy than other machine learning techniques and lower false positives. That is, lower number of fraud clicks are classified as non-fraud clicks. Thank you.